So today we're going to be going over inner products, and what inner products are is if we have the inner product here of u and v, it's going to be the first term of u multiplied by the first term of v plus the second term of u multiplied by the second term of v all the way up to the nth term of u multiplied by the nth term of v. And then the magnitude of u is going to be equal to the square root of the inner product of u with itself, which also means that the magnitude of u squared is just equal to the inner product of u with u. And then for matrices, the inner product of u and v is equal to the trace of u transpose multiplied by v. So now we have this weighted Euclidean inner product, which is saying that our inner product of u and v is going to be equal to multiplied by u1 and v1 plus 3 multiplied by u2, v2. So for here, if we set our u as equal to 1 and 1, our v is equal to 3 and 2, we're able to solve part A. So what this means is we're just going to have our 2 out front, and we're just going to plug in our numbers. So it's going to be 2 multiplied by our first term of u, which is our 1, multiplied by our first term of v, which is 3. And now we want to add 3 times the second term of u, which is 1, multiplied by the second term of v, which is 2. So this will get us 6 plus 6, giving us 12 is equal to our inner product of u and v with this specific weighted Euclidean inner product. So now, question B, we're going to try to do k multiplied by v with the inner product of w. So we will have our w as equal to 0 and negative 1, and for this we'll say our k is equal to 3. So k is just a scalar. So with inner products, what you're able to do is just take the scalar out. So for example, if we had kv and then aw, what we're able to do is we're able to change this to k multiplied by a and then multiplied by the inner product of v and w. As well as if we just had k multiplied by v and w, we're able to just take out the k, making it k multiplied by v and w. So if there's a constant in front of your vectors, then you're able to just factor them out and then multiply them together if there's 2 of them. So for this question, what we're able to change this to is k multiplied by the inner product of v and w, which will be k multiplied by, now we have to use our weighted Euclidean inner product. So it's going to be 2 multiplied by the first term of v this time, which is 3, and then our first term of w, which is 0. And now we're going to add our 3 times our first term of v, or second term of v, which is 2, and then multiply that with our second term of w, which is negative 1. So this will give us k multiplied by, this just gives us 0, and this is negative 6. So if we put our k as equal to 3, this will be 3 times negative 6, which gives us negative 18. So now for part C, we have u plus v and the inner product of w. So when we have an addition in our inner product, what we're able to do is we're going to change this to the inner product of u and w plus the inner product of v and w. So we're able to split them up. So now we just have to do the inner product of u and w, which is going to be 2 times our first term, which is 1, multiplied by 0, plus, now we have to do our second term, which is going to be 3 multiplied by 1 multiplied by negative 1. And now we have to add that with the inner product of v and w, which is going to be 2 times 3 and 0 plus 3 times our second terms, which is 2 and negative 1. So this will give us negative 3 plus negative 6, giving us our inner product equal to negative 9. So now for part D, we want to find the magnitude of v, which, if you remember from the first page, is equal to the square root of the inner product of v with itself. So for taking an inner product of something with itself, it's the same rules as before. So we're going to have a square root, and we're just going to follow the same steps. So it's going to be 2 multiplied by 3, and our first term again is just going to be 3. And now we add it with 2 times 3 times our second term, which is 2, and then multiply it by 2 again, which gives you 18 plus 12, which gives you the magnitude of root 30. So for question E, we have the d of u and v. So what this is this is going to be the magnitude of u minus v, which is the same thing as the square root of the inner product of u minus v with u minus v with itself. So the first thing we're going to do is we're just going to keep our square root, but we're going to subtract u and v. So u minus v is going to be equal to 1 and 1 minus 3 and 2, which gives us negative 2 and negative 1. So now we have the inner product of negative 2 and negative 1 with, again, negative 2 and negative 1. So now what this becomes is just the square root of 2 times, because we're still using the weighted, our first terms, which is negative 2 and negative 2, plus 3 times our second terms, which is negative 1 and negative 1. So this will become 4 multiplied by 2, which is 8, plus 3, which gives us the square root of 11. And now for our final question, we're going to find the inner product with matrices. So here, the inner product of u and v, if you remember, is going to be the trace of u transpose multiplied by v. So what this means is the trace is going to be the sum of all the diagonals in a matrix. So example, if we had a matrix like this, is going to be the sum of all of these ones. So our trace, if we called this A, would be 1, 2, 3, 4, 5. So our trace is equal to 5. So for our question, we're going to ignore the trace for now, and we're just going to find our u transposed times v. So we'll keep the trace there for proper notation, but now what we need to do is we need to find the transpose of u. And if you remember, the transpose of u will take our top left to our bottom right and keep them the same, and then everything else will switch. So this means our u transpose will be equal to 3, 4, negative 2, and 8. So for our question, this means that we're going to want to do 3, 4, negative 2, and 8, and multiply it by our v, which is negative 1, 3, 1, and 1, because our v does not change. So now it's the trace, and we have to do matrix multiplication. So with matrix multiplication, it's going to be 3 multiplied by negative 1 plus 4 and 1. So that's negative 3 plus 4, which is 1. And now for our top right spot is going to be 3 times 3 plus 4 times 1. So that's going to be 9 plus 4, which is 13. And now our bottom left is going to be 2 times negative 1 plus 8 times 1. So that's 2 plus 8, which is 10. And then finally we get negative 2 times 3, which is negative 6, plus 8 times 1, which is 8. So negative 6 plus 8, which is 2. So now that we have our matrix, to find the trace, we ignore these two numbers and just find the sum of the diagonal, which is going to be 2 and 1. So it's going to be 1 plus 2, giving us the inner product of u and v as 3.